have next is a presentation by Scott Kovac of the Nuclear Watch New Mexico. And in your packet is his handout to follow along.
Thank you, Mr. Chairman and members of the board. And it's good to see you guys here today, too. Thank you for coming. I don't know. Manice gave me an hour, so I figured I might as well do an hour. You know.
With Q&A.
Oh, with Q&A. Oh, okay. Well, that's different. I'll try to get done here. Thank you. Let me see if I can do this. Nuclear Watch New Mexico does seek to promote safety and environmental protection at the regional nuclear facilities. And we are concerned and have visited most of the cleanup sites around the DOE cleanup sites around the country. The total cost of our Cold War nuclear weapons program has yet to be paid. Decisions should not be, a byproduct of some distant fiscal struggle. Currently, it's estimated, and this is a DOE number, that nationwide cleanup at all DOE sites is running at an estimated $260 billion. Now, this is for the amount of this represents the amount that the way that the sites want to do their cleanup. And so what happens is every year new things are discovered, the cost goes up. So every year we spend about $5 billion on cleanup for DOE sites, and that rarely covers the increase of costs. Here's a little budget table. You guys have all seen this before probably, but environmental cleanup is running about 10%, about 225 something this year out of 2.2 billion. We would like to see this percentage increase. I mean, that's it's the CAB can make this happen. The CAB can move these numbers bigger, Yes, sir.
Could you explain to me who Nuclear Watch is? Is it independent? Is it somebody associated with something? Who is Nuclear Watch?
Mr. Chairman.
Go ahead.
Thank you. Yes, we're a nonprofit organization. Basically, it's me and Jay. We had our mission statement up here a minute ago. We're basically work on nuclear weapons issues and cleanup issues at DOE sites around the country. We're a member of a national organization of organizations like ourselves that try to promote cleanup across the country at DOE sites. It's kind of an interesting alliance of NGOs that are in the shadow of DOE cleanup sites. Did that answer your question?
So there's Nuclear Watch goes to other nuclear sites there also, or are they looking at Los Alamos primarily?
Oh, I'm sorry. We basically, Mr. Chairman.
Go ahead.
We basically focus on Los Alamos National Laboratory, but other New Mexico sites too. We do pay attention to WIP site. We do pay attention to Sandia National Laboratory and the Pantech site, which is 4.5 hours east of here, is our main focus. Did that help?
That helps, but it doesn't quite complete the cycle.
Mr. Chairman, I don't know.
Joey?
Oh.
Mr. Kovac, your nonprofit, where do you get your funding from?
Mr. Chairman,
Go ahead.
we get it from foundations and from private donations.
Thank you. Go ahead.
Thank you. This is just the location of Area G. We all kind of know where that is, and I will point out that San Ildefonso Pueblo has this triangle right here, basically abuts Area G. Here's an aerial view. 65-acre site started in 1957. It's the above-ground structures are where true waste is being prepared to be shipped to WIP currently, and these structures are on top of much larger waste landfill. This shows a plan view of the pits. Each one of these green lines is a pit. There are full of shafts. So we've got about It's equal to about 49 football fields. That's 32 pits and 194 shafts and 4 trenches, with depths ranging from 10 to 65 feet below the original ground surface. There is also pits currently accepting freshly generated low-level waste. The total excavated volume of these just below ground units is over 1 million cubic meters. Los Alamos site was not selected as a nuclear waste. Was not selected as a nuclear waste dump. It was selected for its remote location and its secret location. This is a geological map of New Mexico. There's two or three things interesting here. First is the Jemez lineament here. This is a seam in the Earth's crust they don't really know when, but you can see all this red is ex-volcano activities and flows. The other important feature is the Rio Grande Rift this way, and right where those two cross is Los Alamos Laboratory and the Jemez Mountains. Okay. Several dozen earthquakes occur in New Mexico every year. And as a matter of fact, the Los Alamos seismic network stations detect roughly 2 to 5 earthquakes each year in the Pajarito Plateau. This is another cross section under Morton-Dad. Under Morton-Dad Canyon, down Morton-Dad Canyon. There's a couple of things here. First off, there's a fault zone that you can see the displacement. This is a conceptual map. This line represents the water table, approximately 800 feet below the laboratory. Here is regional well 34, and it has found a volcanic cinder cone here. Cinder deposits of more than 50 feet occur in wells R20, 21, 22, 34, 39, 41, 49, 53, 54, 55, and 56. These cinder deposits range in composition, different composition, and they indicate that multiple vents are in the vicinity. And the important thing is that each one of these interfaces between 2 different geological levels underneath the laboratory can provide a pathway for contaminants to the water table. And certainly a cone like this can provide a pathway also. This is a fault map of the area. And you can see the Pajarito's plateau is pretty much fractured on the western boundary from TA16 up to TA3 or so. Area G is about here. You can see that there are some other fault zones indicated and some other little things here. The important thing is that this is the mapped faults, and so there may be unmapped faults, still undecided. And there have been scientists that say a 7.0 is due at some time. A recent study in 2009 by the laboratory concluded that no faults in the last 10,000 years were present at Area G, but it's still a very active region. This is actually a water map, but it shows a little wiggle in the water table. Each one of these blue lines is a striation of the top of the water table, going down about 20, going up about 10 feet at each line. This is marked faults. This is in the Corrective Measures Evaluation report. And there's 3 or 4 of these maps showing different conceptual flows. And I would just like to say that the conclusion is the lab did another report in 1995 that said every 100 years or so, a magnitude of 6 or greater earthquake is will be considered to occur.
Scott,
Yes.
I have a question. If I'm looking at this right, am I to guess that TA 54 doesn't have a fault zone, or there is fault zone in 54?
There are no mapped faults. There are a series of smaller faults that were concluded, but as far as certain, but none have been actually mapped yet. But really, if we go back a slide or two, like to here, really, it's only 3 miles to this heavily fractured zone here, and it's only 3 miles or 3 or 4 miles to the Rio Grande Rift zone. So it's in between, and don't forget that the Rift zone is pushing the rocks this way, and so it's in between here. But currently there are none known or none mapped.
Thanks.
Thank you, Mr. Chairman. Much has been made, and there was a presentation given to the CAB last fall or sometime, I believe, that went into defense in depth. And when you go and look at DOE order 420-1, it covers the defense in depth, and this is things that you must take into consideration when you're citing a nuclear facility. And the first thing on the list in citing a facility is choosing the appropriate site. And the second thing on the list is minimizing the quality of material at risk. So the laboratory, the landfill is, they didn't take siting into account when they built the landfill. It was not chosen as a landfill. It was chosen as a secret nuclear weapon site. This is a good shot of an unlined trench, moving some sort of equipment in. You can see the seams between the different volcanic lava flows, and you can see the gaps. You can also see the fractures in the tuff. This shows an aerial view of some solvent plumes. The important thing about this is that these plumes are, are considered to be ongoing source for TCE and TCA vapors. And TCE and TCA were solvents used in the production of nuclear weapons back in the Cold War and for experiments. And this is a plan view, a conceptual plan view from the laboratory showing the plume down to nearly 200 feet below the ground surface, which is, a quarter of the way to the aquifer down here somewhere.
Scott, is this what we know as a chromium plume?
No, Mr. Chairman. This is a plan of, this is a plume that they've just, mapped out at Area G. So there's 3 of them. There's a little one here, and a bigger one, and a bigger one here. So these are solvent plumes. They consider that, for instance, that this one is still higher than it was when it was first disposed of, because these are some of the earlier pits here where they apparently disposed of much solvents in this pit, and it's still higher than it's been. It's still high for like 40 or 50 years here. It still is reading this, so it's an ongoing source of solvent plumes. And this okay, and this is just a map showing the migration of plutonium and other radionuclides off of the TA site, off the TA 54 in Area G, and these are all plutonium and tritium. And the title of this is, and this is from the CME that we're talking about, and radionuclides detected above background value in the channel sediments. So this is on the surface, probably or possibly contaminants that have washed off of the top of the hill, maybe in this channel here. And these are all, you can't really read them now, but the plutonium is all averaging about 0.2 picocuries per gram, and background is considered to be 0.04 picocuries per gram. So most of these values are 5 times background in the soil surface. And this just is an example of how the contaminants have migrated off of the site. Oops. Oh yeah, here's a close-up of some of those numbers. Like for instance, this is 0.4 picocuries per gram, and background is 0.04. So this is 10 times background value here.
Mr. Chair,
Go ahead, Jared.
Scott, so are these migrations, or are they possible dump sites? Or sites that, do they have a logical runoff area? In other words, could something have taken them down to that area, or they just existing on readings right now?
Mr. Chairman.
Go ahead.
Yes, Gerard, I think that I believe that the lab would say that there is nothing really was ever buried there out here down in the canyon bottom. I believe that this is either possibly blown off in the air or washed down the side of the hill, possibly in an earlier time when the pits were open, or don't forget these.
Excuse me, so migration, not disposal.
Migration, yes, sir. Thank you, Mr. Chairman. There's also many boreholes around area G. This shows us, this is just a slide of down to 60 feet. And so here's another plate, not in the CME, but within the last decade or so, showing the corner of area G here, showing some of these sample locations. Now this concerns me very much because the radionuclides detected above background values in the subsurface tuff. And if we go to the next one, this is a takeoff of borehole number 37. This is some sampling numbers here. And you can see that all the way down to 200 feet, which is, I believe, the depth of the borehole itself. It's plutonium-239 is at 0.2 picocuries per gram. And don't forget that the background value on the surface, and I'm not really sure, I need some explanation if there's background value down at 200 feet, but there's many sites, many samples that were taken this low. So this is basically 5 times background down at 200 feet. So clearly shows that the contaminants in area G are not contained, or were not contained, are not contained. Oops. On a volume basis, most of the waste at area G has been disposed of in pits. Before the mid-1990s, the waste was typically placed in the pits in lifts. Each layer of waste was covered with uncontaminated crushed tuff and compacted using heavy equipment. Most of the waste placed in the pits was packaged in plastic bags and cardboard boxes. The waste packaging requirements at disposal and used before 1990s are generally expected to. I'm sorry. Let me start over. What they did was they did it in lifts, and there's drums, and then they would put a layer of dirt on it, and then crush it with heavy equipment. And the people making people disposing into these pits were more concerned with filling all the voids between the drums. And so they would get a nice layer of dirt and then roll over it with their heavy equipment. We can only imagine that this crushed many of the drums. We can only imagine that that now all the volume, or a major portion of this volume of excavation that's been backfilled in between the waste is also now contaminated. So that's where we get. So this is, I'm not sure the numbers on these pits, but you can see some storage boxes. You can see some drums being just buried over. This is a table from the CME showing where we get the million cubic yards from. This is the volume of the pit, the cubic yards, and here's 1.4 million cubic yards. Here's the amount of waste, approximately, an estimate by the laboratory, 200,000 cubic yards. So somewhere between this number, the fill that was put in here into those trenches, most of it's going to be contaminated, we think, more than likely, and at the very least, it all has to be dealt with if you decide to excavate those pits and trenches. Okay. That equals approximately the volume of the Empire State Building. And I just put this picture in here just to say, it was built by man. It's a lot of stuff, but it was put there by people. The trenches were dug by people. It is doable. Here's another trench out of the Corrective Measures Evaluation, the CME for Area G. This shows kind of a continuation. It shows the pit numbers down this side. It shows the date of operation of these pits. It shows the size of the pits. It shows the excavated size of the pits. It shows the field measurement of the pits. and this is the amount of waste in the pits. And so, the cubic yards, so, like pit 24 has 7,000 cubic yards, in a, 38,000 cubic yard hole. But, we have to figure that most of that is probably contaminated at this point, and at the very least has to be sorted through. As it turns out, we have a picture of these two trenches when they were built, or when they were dug. Once again, just showing the unlined pits, showing the fractures, showing the strata. Every one of these, everywhere where there's a seam like this, is a possible contaminant pathway. And here they are unlined. It's interesting that, It's interesting that, modern landfills, even, the Santa Fe County landfill, and has to be lined. It has to be a lined trench. So, but these are not lined. Here's another slide of the monitoring network. We think that this shows the water table map that's in the CME, and it shows, these lines once again are from, estimated in here from shallow screens at these well locations. So these locations have, they've kind of filled in here with the top of the aquifer, and the different maps represent alternative conceptual models related to uncertainties associated with the flow of the aquifer. So they have different maps. So the point is, the water flow is still unknown, and there's different concepts, and there's different ways it could be, and there's also no monitoring wells to the north towards San Ildefonso Pueblo. Here's another cross-section showing yet another well that intersected a volcanic vent. It shows a cinder cone here. And each one of these each one of these seams is, a potential pathway for contaminants to the water table, which is here. Okay. The CME, the Corrective Measures Evaluation, has two solutions. One is the preferred solution, picked as the preferred solution by the laboratory, was to cap and cover the whole area G. That was going to cost $386 million for the cap and cover. It would be followed by 30 years of monitoring vapor extraction and a century of institutional controls. Actually, I think it was only 3 years of vapor extraction, maybe, total. But, they were only going to monitor the cap and cover for 30 years. Here's a conceptual drawing out of the CME. Excuse me. A cap and cover, as good as it may be, and they're only, the plan for the cap and cover was only 9 or 10 feet deep, with slopes, going off. So, really leaving all the waste in place, it allows the buried waste to permanently threaten our aquifer. And, thank you. Okay. Next, the The other method of cleanup was excavation and removal. LANL's estimate was 29 billion, and this was the full excavation of 100 pits and shafts with off-site waste disposal and excavated areas backfilled with clean material, costing 29 billion. This would be 30 years complete and an estimated 108 million worker hours. The 29 billion included almost 1 billion in design, 7 billion in overhead, and 9.7 billion in contingency. This is about 30% contingency after, we've already spent $1 billion designing the removal of waste out of a landfill. So it just seems kind of extravagant to me. That would, the cap and cover, they'll have inspections and maintenance for 100 years, but really, plutonium-239, the half-life of plutonium-239 is 24,000 years, and it remains an environmental threat for 10 half-lives, which would be 240,000 years. There is a solution. There's another idea. DOE has recently approved a privately owned low-level waste dump for waste control specialists on the Texas-New Mexico border near Eunice, New Mexico. This facility has liners and concrete cells for the types of waste arguably less hazardous than the older waste in Area G. This was approved by DOE. It was design help from the Los Alamos staff, and the 29 billion Area G, the cost for cleanup of Area G was done before this site was in operation. Now you can see these slopes of the lined bottom of the place, and I guess you guys have all maybe been there recently. Yes, I'm sorry. They won't let me go. For some reason, but I'll get in. But anyway, I think this is some of the higher waste here. This may be low, type B or C, low level, into these little concrete vaults. There's a concrete floor under this. There's several layers of clay. It's all pitched to a collection system that immediately collects anything that escapes out the bottom of the waste site here. This is a picture of MDA B at Los Alamos. It took place in large metal structures that resemble airplane hangars on wheels. When unexpected contamination was found, it was contained inside the filtered enclosures. There was no real serious injuries reported. And yes, so there is a solution. And this is an interesting comparison. The excavation of MDA-B yielded almost twice as much waste, almost twice as deep, 10 times the amount of curies as they had originally estimated. Yet the total project cost only increased from 110 million to 136 million. If you break that out, there's different ways to break that out, but 136 million for the 43,000 cubic yards is about 4,000 per cubic meter of waste to dispose of it. It's a little different than the estimate for MDA-B, for Area G. Here's MDA G at 29 billion. That works out to about $20,000 per cubic meter of waste, assuming the 1.4 million. So you can see that that's like 5 times the amount cost per cubic meter. if you take these numbers, if you take this 4,000 per cubic meter for waste excavated and disposed of, and you plug it back into MDA, B and C costs, you can come out with a $5 or $6 billion figure instead of the $29 billion figure. Just kind of comparing it. So why does it cost $29 billion instead of $6 or $7 billion? We don't know. We think that it's the perfect place to start would be at Area G. There is some retrievable true at Area G, and especially in Pit 9 was one of those pits that is retrievable true that they're going to go get the waste out of there. And so that leaves a big void between pits 8 and 10. I mean, why not? You've got why not go do a pilot program or do something besides just cap and cover? I mean, they're planning on, I'm not sure what they're going to do with Pit 9 once they excavate the retrievable true out of it, but, are they going to throw more low-level waste in there or, backfill it with clean waste? But, you have some pits right on either side that you can, just go get it, let's go get it. It'd be a win-win that permanently protects the environment and creates jobs. When the first version of this Corrective Measures Evaluation came out, Nuke Watch and several other people had suggested other alternatives for cleanup. And a couple of them that we suggested that they please look at were a RCRA-type landfill. This was before WCS, and WCS is like way better than any RCRA landfill. And so we suggested, well, put it in a better landfill, take it out, and and we're not saying put it back at Los Alamos. We're not saying put it at WCS. We're saying this is a discussion we have to have. But if we cap and cover, we don't have that choice anymore, and we need to put these landfills back on the table. The reason given for not continuing on with the landfill, and as a matter of fact, this one cost, the Laboratories estimate was $17 billion on this estimate. So a little bit more than half of the $29 billion for removing the waste, characterizing it, shipping the high-level waste, shipping, just dealing with it. See, the main problem, our main concern at Los Alamos is in Area G is the waste is uncharacterized. It's been dumped in there. It was basically from 57 to 87 or 77, 20 or 30 years. It was just a free-for-all, and they could do any waste. It was unregulated or self-regulated. And I'm not saying anything, derogatory. I'm just saying that's why they did it all over the country. And so, we don't know. The records are not that good, so we need to look at it again. And we need to re-examine these landfills again because the reason they gave was that a new RCRA, which is Resource Conservation and Recovery Act, landfill would require a siting study and permit approvals, including public comment. This option would delay the final action through permitting approval process and construction of the new landfill. This delay would impact the consent order, corrective action requirements. Well, by now, the consent order has been delayed and impacted already. So this reason for not, keeping the landfill as an alternative has been kind of superseded. The consent order is, who knows what's going to happen to it, but it's going to be extended. It's going to be delayed. And so therefore they eliminated it. And this is the reason given. There was another one, corrective action management units alternative that they also estimated for $17 billion. And this one is like a building or maybe a bunker or some sort of warehouse where you can store the waste and keep an eye on it. And for the same reasons that, so that it would, the delay would impact the consent order. And so it would take too long to do this. So it was not continued on as a viable alternative. Meanwhile, disposal continues at Area G. This is a Google map image from May 2002 showing waste containers, probably bags of stuff from maybe MDA G or something being covered over with backfill. And at this end of the thing, at this end of the site, or this end of the pit, this is pit 38 here, they're digging, and so they actually by now have extended this into here. So they're still considering the use of MDA G as a low-level waste site, still in unlined trenches and still in these unlined pits. And I just don't understand. Anyway, excavation would provide jobs. We've learned that the 3706 campaign currently employs about 400 workers. And, we need to keep those guys, they're trained. Cleanup of Area G could be, create hundreds of well-paying jobs for 20 to 30 years. So we have some requests of the CAB for recommendations to DOE. We recommend against cap and cover of Area G. We recommend re-examine the other cleanup alternatives, such as the landfill and the Corrective Measures Evaluation unit, and complete excavation. We also recommend that we ask that the CAB recommend to DOE to re-estimate the proposed costs of cleanup, because the original estimate to excavate was inflated, or they were tied into certain DOE ways of estimating things that maybe didn't apply or something. There's got to be a better way. And we would also advocate for steadily increasing cleanup funding to $400 million a year, up from the current almost $250 million per year. And we appreciate the 3706 campaign. We think the lab can do more than one thing at a time if they had the money. This is just a slide stating the $29 billion again. Okay. The lab has deferred much cleanup for the sake of the 3706 campaign. There's a list of things that have been extensions given to the laboratory, and it's kind of an old date here, from 6 months ago or longer. But there's 60 or 70 or 80 extensions, and these extensions are all at the sake of the 3706 campaign was being funded while other things were not being funded, and there's other cleanups, and we're not saying $400 million like next year at the sake of everything. And we're not saying, excavate Area G at the sake of everything else. We're saying we need to work our way up to that. We need to, stop cap and cover. That'll give us time to think about, what to do, what the priorities are. I mean, we think that the chromium plume, for instance, is very important, and we're not saying don't do that. But to just cover over Area G, it's just the wrong way to approach it. This is a slide we had. The laboratory was able to sample minerals on Mars. They could certainly sample and recharacterize the waste at Area G. And thank you.